Yeah. Thank you so much for having you back, Preet. Yes, I'm glad we got all of the awkwardness out of the way. I knew there was going to be something. It was in my nightmare last night. Glad it's over. All right. Thank you so much for our host, for people having us. This is a really unique space for design, by the way. This does not happen a lot where you have leaders and topics that are so relevant and just so much great content. So, round of applause for everyone who put this together. And you guys are incredible. Thank you, Grease. My name is Jessa. I'm currently head of design for Byte by Yum. Byte by Yum is the one of the largest AI-driven platforms in the QSR industry. QSR stands for Quick Service Restaurant. Our brands include Pizza Hut, maybe you've heard of it. KFC, also something you heard. Taco Bell, anyone? Anyone? All right. Habit Burger. And we are in over 55,000 restaurants in over 100 countries. So it's big. Throughout my career, having led design in Walmart, having the head design at Capital One, done startups, innovation design, one of the core tenets of the design field is that the pace at which our design change and adapts to technology. So today I want to talk to you about the frontier of what I am seeing in my role as a new frontier for design and for design interfaces, which is actually going to be, I think, no interface. This is where voice AI interprets meaning and tone. And to illustrate this, we're going to start with a little experiment, okay? Hope everybody is awake because it's going to get fun. All right, here's the experiment. How many meanings can you make from the following sentence by simply changing the inflection of one word? Let's try this, shall we? I didn't take her wallet. I didn't take her wallet. I didn't take her wallet. I bird. Um, I didn't take her wallet. I took yours. I didn't take her wallet. Say 5 words, 5 totally different meanings. So if a simple 5-word sentence can carry 5 meanings depending on tone alone, think about what happens in a real world situation when you are using voice AI to do something like order food or manage inventory for markets that are 3 times the size of where you are today, or in languages that range from understood to not even in our system. That's big. This is the hidden physics of conversation. It's the way that tone, lilt, and tiny will change the intent. And this is exactly where a lot of voice AI systems fail. This is a lot of where LLMs actually fail. And I want to talk about it today because it's one of the ways we're experimenting in Yum. So let's talk about what is voice AI. This is on the bleeding edge of things. So here's what voice AI is. Voice AI refers to a system where natural language processing, and an NLP, and automated speech recognition patterns and machine learning come together to enable human-like spoken interactions between people and digital systems. Unlike a traditional IVR, which is, kind of like your bank, like, please press 1 to be connected, right? That's an IVR, okay? Which it's rule-based and it's fixed commands. Voice AI is very different. It's a little scarier than that. Voice AI can actually interpret your intent. It can interpret the context and emotion, and it learns and it actually adapts. It doesn't just transcribe. So how do you design a system that adapts with conversation faster than you can actually compute? Voice changes everything. Why is voice AI challenging? It's because voice changes everything. And when you think about AI, you might think about Alexa or maybe some like customer service bot that you can barely understand. But voice AI is truly going beyond that. It's the next level of design. It's any system that cannot only just interpret what we say. So it's not just speech recognition. It's actually human recognition in terms of intent. At Yum, you may have seen some of this in the news, and I'll have this coming up in a minute. You may have seen some of this in the news where we are actually experimenting with voice AI in our ordering system. And you'll see a really funny headline coming out soon. But we are experimenting with this. So why is it a challenge? Because humans can hold an entire conversation with just sound. That is how incredible our communication skills are. And if you don't believe me, let's try this. I'm gonna hold an entire conversation with just sounds. Uh-huh. 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 Mm-mm. Mm. Mm-mm. Mm-mm. Mm. Mhm. That was an entire conversation. I've had that conversation on the phone with my in-laws. Yeah, that was just sound. Humans are wired to parse meaning from tone and timing. You don't even realize you're doing this. We have a conversational baton going on right now. You don't even realize this is happening. So, the question for us designers is, how do you teach AI to operate in this invisible layer of sound and silence? That's where this term comes in. This term is called porosity. I want to introduce what I'm calling the porosity principle. Porosity is the pattern and the rhythm of sound. It's traditionally used when we talk about poetry, but it's coming back in AI because it is the way that our tone and our sound move through the voice in conversation. You see? That's porosity, the warmth and the lilt. So humans don't just design flows. And in voice AI, we don't just design flows. That's actually at the very, very surface. That isn't even the prerequisite. We design for lilt. We design for silence. We design for stress and for tone. And without porosity, without really understanding how those things interact in the model, AI can't really hear what we mean. Your system is going to be smart, but functionally stupid. What this means is a few things. There's quite a few, but I want to touch on 3 that are important for a designer. What this means is that memory is now the new UI. When users speak, you carry an entire state of conversation, an entire system in your head. There's no visual breadcrumbs, there's no progress bar. So designers have to build memory scaffolding into voice itself. Recaps, confirmations, context cues. A spoken interface is still going to need navigation. It's not IVR. IVR is very fixed. Press 1, press 2, you can't go back. Voice AI, you're able to do something as simple as going, "Oh, my order was wrong. I need to change my order." Great, you need to change your order? Let me know. What do you want to change it to? That is a very complex system. So every designer, you heard like a system go, "Sorry, I didn't get that," right? That's not recovery. That's actually regression. In voice AI, your recovery starts to adapt and listen. So we need a resilience layer. We need to detect confidence thresholds and route gracefully and shift that modality. By the way, this is all stuff that we are learning new. There's no playbook for this. So what do we do as design? I take my role very seriously as design leader in understanding that we are entering a new phase of technology where what we say and how we put these systems together become the principles for how they are built in the future. So this means that silence is going to be a design variable. It's not going to be obvious today, but it will be a design variable as AI systems start to talk to each other. Our research shows that conversation gaps between humans, they hover around 200 milliseconds. 200 milliseconds. That's actually faster than conscious human thought. That's faster than any AI model can actually compute today, which means our conversations are rhythmic. And we've spent decades defining standards for things like screens, for colors, for grids, for systems, for typography. And AI is starting to automate a lot of that. But in voice AI, we don't have the same playbook. And when the interface disappears, voice becomes the interface. So it has to carry trust, it has to carry intent, and has to carry emotion. But if we only design the flows, which is where a lot of teams, and where I've talked to a lot of teams doing this, they're only designing flows, scripts, and decision trees and dialogue states, and not really looking at the deeper human mechanics of the psychology of language. So, what I want to do today, and this is based off of a lot of what I'm learning, not only as a designer, but as a design leader at Yum, what I want to do today is propose something new. Think of this as the first draft of design principles for voice AI. It's kind of the same way we once codified, heuristics for GUIs. These aren't tips or tactics, all right? They're laws of invisible conversation that I have run into over and over and over again, and you should learn from my mistakes. These are universals that I feel strongly that every voice system needs to start honoring if it's going to feel natural, if it's going to feel trusted, and it's going to feel scalable. Now, these are going to sound obvious when I say them, okay? I'm going to say them and you're like, ugh, whatever. But here's the challenge. None of our systems, including the ones that we are currently testing at Yum, which I want to change, by the way, none of them are really designed around these principles yet. That's why when we ran a UX study on our system against 5 competitors, I won't tell you which 5, and I won't tell you which system, all right? Every single score came out under 40. That's 40 out of 100, which tells me, okay, in the industry, no one has this figured out yet. So let me walk you through what I'm calling the 5 laws of invisible conversations. Here's the first law, the emotion principle. Again, this is going to sound really obvious, but the emotion principle states that every sound carries feeling. Now, what this means, when I sigh, you know I'm frustrated. If I go, yeah, you can carry a tone from that, right? When I gasp, you know I'm surprised. No words, but you get the meaning. In fact, UC Berkeley research, they mapped 24 distinct emotions that are carried by a single vocal burst alone. And that is transcultural. 24 different emotions from a single, right? Yeah, that can mean a lot of things. Nonverbal sounds carry a structured meaning across cultures. That's what this principle means. Our brains map them instantly. You don't even realize you're doing this. But if our systems start to ignore these systems, if we are creating systems where our models are just looking functionally, they're going to be very deaf to what the human intends. Because voice AI is starting to be built in more and more systems for large companies. But here's the second law. I'm going through these quickly. There's a lot of research behind it. Talk to me afterwards if you want to know some of the stuff. The second law is this. It's the law of rhythm, which is that humans take turns in a conversation at a fifth of a second. And here's what I mean. You and I, if we started talking, there is a conversational baton that you and I hand off. It's in micro moments. It happens at a fifth of a second. Did you know that? In natural conversation, these turn into what are called tight clusters, like a little baton, okay? Where one person talks and the other person responds. That is the rhythm. We do it with our body, we do it with our voice, we do it with our faces, right? It's called a tight cluster. Humans make this exchange, regardless of culture. You and I can make this exchange at 5 beats per second. That is faster than human conscious thought. That's incredible. Humans are incredible. These bursts, these little tight clusters, they form what we call turn clusters. These are short, rhythmically aligned sequences of talk that feel alive and feel connected. A gap in these clusters, for example, a gap when your model is trying to gather data and it's quote unquote thinking. Yeah, that's a gap. Goes, hang on, wait just a minute. There's a gap, right? If there's a longer than expected silence, the rhythm breaks. Okay, so the rhythm law says that the human brains, these gaps are social signals. It's hesitation or confusion or rejection. So you can't ignore these. If you have engineers going, oh, yeah, it just takes a long time. The model is rendering. We have to pull the information. You need to help them understand that is actually a social cue. We are going to lose people with that social cue. So humans instantly feel a gap in this rhythm disruption. If you have a conversation with someone, try this out. You're going to start noticing it. Timing is now the hidden syntax. What this means is that we have to now design for timing. Designing in voice AI, what we've learned is that we don't just design words, we design when they happen. The pacing and the rhythm is extremely important. This means you need to take turn taking as a rhythmic structure. If you are starting to design for voice AI, it needs to be a rhythmic structure, not an input-output. An input-output is what your data model is going to be, but a rhythmic structure is how you humanize the data. That is going to be hard. None of this is easy, but it is very fun. The next law, law number 3, is what I'm calling the tone effect. Tone predicts trust. Here's what I mean by this. Did you know that you, as a human, you can hear and predict risk in less than 10 seconds? You don't even realize you're doing this. In a medical study, there was a brief 10-second clip of surgeons speaking using tone only, and surgeons who had harsher or more aggressive tones were predicted to have more malpractice claims. Did you know that? We can hear risk. So porosity alone, like that warmth, that sharpness, it can change the trust and the real world consequence. So if your content is controlled, but your porosity is not effective. For example, what if I did my whole speech just like this? You would feel extremely stressed out, wouldn't you? You would feel stressed out. That's the porosity of tone. So if your porosity is not effective, if your stress or your tone or your lilt is off, you're not going to get the same reaction. You're not going to get the same trust. So what does this mean when we're designing for voice AI? This means you need to add a porosity feature layer. Things like pitch, intensity, spectral lilt. How high does your voice go and how low does it go down? Those things matter. You need to add a speaking rate to your NLU to detect the effectiveness of these before choosing the next dialogue act. This is really important, especially with your recovery act. And number 5, the repair rule. This rule states that nearly every language has some version of, huh? Did you know that? That nearly every human language has some version of, huh? And that version of, huh? That's actually what we call a conversational band-aid. It is a repair. We are trying to repair the conversation, which means what? Voice comes before language. You understand voice before you understand language. To demonstrate this, have you ever heard a PSA announcement and the language is just kind of knew it was a system? Like this.
您好，您所拨打的号码是公主根号，其地位号码4台114台后台拨，谢谢。您好，您所拨打的
Yeah. You get the point, right? Emotion starts as a sound. You don't have to know what language I was speaking to know that that was probably some sort of recording announcement. Yeah, from my childhood. So we need, yeah, it was from childhood. So we need to design for sound before we design for speech. That's important. When we design for sound before we design for speech, we're taking porosity principles into effect. And here's the last one, law number 5. This is what I call the connection constant. All right. And again, these seem really obvious, but when you start to add them to design and technically, you start to realize how complex they are. The connection constant says that the smaller the silence, the bigger the connection. This is a social principle that humans use in conversation all the time. When you and I are in conversation, when we had a smaller gap in response, that conversational baton, it actually correlates with a higher sense of trust. Recent conversation studies actually showed something really fasty. The faster we respond, the closer we feel. This is very simple. Imagine if I said, hey, oh, hey, what's up? Right? Versus, hey, oh, hi. Right? The faster you respond, the closer you feel. This is a social connection that humans have done, is an evolutionary response. So researchers found that shorter response latencies, even in milliseconds, can directly correlate with a stronger social connection. So your data latency, your model's data latency for your voice AI really matters. And by the way, don't do what some models I see have done, which is they put like fake typing noises in the background. Like you start out going, hi, I'm your voice AI assistant. And then in the background, like, do you think I'm stupid? You just told me you were fake. But these conversational like gaps, they create a social connection. And we have to understand when you start to take humans out of that and AI starts to actually start creating a conversation, these psychological aspects become very important for how well your product is going to work with your customers. So silence is not just a pause. That's what it means. Silence is not just a pause. It's a signal. If it's too long, your bond starts to fade. So silence and pacing is literally shaping the perceived warmth for a conversation. So what does this mean? Timing is the interface. Syntax is the interface. Pacing is the interface. The intangibles has suddenly become the thing we need to design for. Why does all this matter? Well, because this is not 5 years away. This is happening right now. So some of these companies, there are others, but yeah, you see the Taco Bell one? Exactly. This is happening today. Yeah. These companies, Walmart, SoundHound, and yes, Taco Bell, my backyard, all right? We're already experimenting with voice AI in real high volume environments. So for example, Walmart is actually investing in what they're calling AI super agents. So they're investing in tools that are going to predict and anticipate intention before you even speak. Before you speak. May I remind you that that is the emotion principle and the rhythm law in action. That's exactly what I'm talking about. It's happening today. And that, yeah, we are already integrating voice AI into our drive-through. We are already integrating voice AI into some other stuff that I can't talk about, but it is really cool. So for me, this is not only pertinent, this is my job. Before we had words, we had tone. Before we had touch screens, we had touch. Voice is our oldest interface. It is our most human interface. So what do we do in this new Wild West? Here are some things that I would like to propose that as designers, we need to start solidifying. One, you need to codify human laws. Turn emotion, turn rhythm, and repair into actual design standards. These should become the heuristics. Just like we have Nielsen's 10 heuristics for a screen, we actually need to have voice heuristics that we can use to say what is the actual, what is the standard of how we want to talk to people. We need to design for prosody. Prosody, again, that tone and that rhythm and that intent. We need to make interruption, correction, and silence part of the experience, not just system errors. Right now, they are just system errors. But we have to understand those system errors are actually social cues to the human ear. We need to build voice literacy across teams. Data literacy, love that top. Tech literacy, love that top. The next wave is going to be voice literacy. Teaching your designers even the concept that voice AI is here and it's not going away. We are going to have to design for systems that talk to systems. So, training your PMs and your engineers and your execs to understand just the concept of prosody. The concept of spacing and conversational psychology is going to go a long way because I guarantee you, every CEO is like, we want AI to do what? We don't know, right? This is your moment to interject and say, hey, did you know that human conversation is actually a lot more powerful than you think? We need to partner with data science ethically. What this means is we need to decide what signals to use and what not to use. Before we say, oh, we should automate this, design, you need to ask, should we? Not can we? Should we automate this? Decide which signals and which signals not to use that can have prediction, never replacing permission. That is a big thing. Even though our voice AI system can predict when you're mad or angry or hungry, or maybe you just want a taco, right? We should not replace that prediction with the permission to do something on your behalf. That's where designers bring the humanity back into this. We're going to need to prototype for tone and for emotion, as well as flow, all of them. Testing, we're going to need to test things like warmth, like pacing and silence, the same way we test usability. We're going to need new metrics, and we are actually experimenting with some of these metrics in Yum. It's very interesting. But how do you measure trust as a KPI? This is one of the ways that we're finding we can measure trust as a KPI by using some of the oldest human psychology that has ever existed. But we need to lead the governance conversation. Advocate for voice standards in your org. Things like accessibility, escalation, tone, bias, cultural adaptation. People with speech impediments should be able to talk and converse with your system just as easily as anyone else. If you have an accent, if you don't quite understand, if you have a hearing disability or even a motor disability and you're talking to a system, we need to have design accessibility standards put in as part of this. Meaning we need to design for not just the edge cases, we need to design for the extreme. So ending all of this, trying to go fast because I know we're behind time. As design leaders, our legacy is not going to be how beautiful our screens were. That is not going to be what's on my tombstone. Okay? It's going to be died by paper cuts. Our legacy is going to be whether or not the system we built could understand us. There's my timer. Boom. Because we didn't have a timer. So our legacy is going to be in whether or not we taught AI not just to respond, but also to relate. That's the key. Because every word, every pause, every sigh, that is now designed too. That's designed. And we have to intervene now as design leaders because voice AI is already shaping how the world is going to speak and listen. There are aggregators using voice AI now talking directly to other aggregator systems where the humans are absolutely removed. How do you design for trust in that situation? We need to design for the way the systems learn to sound, how it will create trust, not just how well it understands the output of intent. Because when the interface disappears, all that's left are tone, our timing, our humanity.
That's what's left.
And that is the real design challenge. That is the real opportunity. Thank you.